So in this lecture we are going to discuss the kinematic, very first chapter of the class 11, right, in which we will discuss the motion of a body in a straight line particularly, right. So before going to get first of all, tell me what is the rest and motion. What is rest and motion? Right, I am describing this in a brief, right. What is the rest? You tell. If suppose this is the body and it is not changing its point, its position with the time, the body is said to be at rest, right. If the body is not changing its position, right, with time, the body is said to be at rest, right. Body is said to be at rest. All right. And what about the motion? If some body is moving, right, and it's changing its position, right, if the body is changing its position, right, with time, the body is said to be in motion. You understand or not? For example, listen one thing. If it is a car and it is moving with velocity, right, and it is at rest, right, it is not changing its position. So with respect to ground, if you are standing on the ground, right, with respect to ground, this body is said to be at rest and this car is said to be in motion. Understood? But it is not enough to define the rest and the motion. For example, suppose there is a long cart, right, and you are standing over here. This is the person P1 and this is the person P2 on the ground, and there is a block of mass m, which is, if this distance is x and x is the constant, and if it is moving with velocity v, you understand, the person P2 is standing on the ground, right, on the road. It is moving with speed 10 meter per second, suppose. Is it clear or not? And this block is not changing position with respect to person. Are you getting or not? So this is the block with respect to person is at rest. The block M, right, is at rest. It is said to be at rest with respect to P1, while the same block M is moving, is in motion with respect to person P2 and on the ground. So the same block is at rest and same block is on the motion. What is the difference? The difference is of the frame of reference. If the frame of reference is ground, that is, you are observing this block from the ground, then its velocity is same as that of the velocity of this cart, right. But if you are observing the same block from the cart itself, it is not changing its position and therefore it is said to be at rest. You understand or not? For example, if you said, what about the motion of this pen? With respect to me, this pen is at rest. All right. But if this pen is seen from the moon, right, so definitely from the moon, this pen and me also is moving with a very high speed with respect to moon. So the rest and motion are not absolute. The important point is that rest and motion are not absolute, right. Rather, therefore, rest and motion, right, right, depends upon choice of frame of reference. Understood? From which frame of reference you are observing the motion of the body, right, it depends upon that. So rest and motion are not absolute, rather they are relative. You understand or not? So if a body is at rest, so it is not said to be at complete rest with respect to some frame of reference. For example, if you see the tree, right, with respect to ground, tree are at rest, but when you are moving in a car and you see a car, when you see the trees, right, very away from you, from the moving car, so you will see the trees are going backward. Have you seen that? Right. So this, the rest and motion are not absolute, rather they are relative to each other, and rest and motion depends upon the choice of frame of reference. Right. Still, we will assume the ground as our frame of reference here. Right. With respect to ground, we will try to observe the motion of the body in most of the cases. Is it clear or not? Right. Copy this. So rest and motion depends upon the choice of frame of reference, although there are two types of the frame of reference. What is the frame of reference with respect to which we observe the motion of the body is called the frame of reference. Here the frame of reference is the ground, here the frame of reference is our cart, right? The two types of the frame of reference, two types of frame of reference we are going to discuss. First is inertial frame of reference, and second is non-inertial, right? Non-inertial frame of reference, right? What is the inertial frame of reference and non-inertial frame of reference, right? I will discuss this in detail in the NLM, Newton's laws of motion, right? Here no need to discuss all about this, right? Only you may assume that the inertial frame of reference is the ground, right? The ground is the inertial frame of reference. In this chapter, you may assume only that. What is the difference between that? It will be explained, right, in the NLM in detail, right? Copy this. So the next topic is our distance and the displacement. Displacement, right? What is the distance and displacement? In brief, I will try to explain. Suppose the point is over here, some person is or the object is over here. If it is moved to this point, right, then the path length covered during the motion from point A to B is called the distance. What is the distance? Path length covered. Path length covered during the motion. During the motion is called distance. Is called distance. This is the first thing, right? It is a scalar quantity, right? Scalar quantity. SI unit is meter, right? It is a scalar quantity and SI unit is meter, right? Represented by meter. That's it. What is the path length? This is the path length during the motion. This is called the distance. And what about the displacement? Listen one thing. If this is the initial position and this is the final position, although it is the definition given by most of the student and teacher that the shortest distance between the 2 points, that is, this is the shortest distance between the 2 points is called the displacement. But here for the NEET preparation, if this is the point A, this is the initial position, this is the origin, this is the R1. What is R1? R1 is the initial position vector. Initial position vector. All right. And this, when it move along this path and reach to the final position V, so this is the R2. What is R2? Is the final position vector, right? And the AB vector, this is the R, right? It is the displacement vector. Displacement vector. What will you say? The R1, the position vector is nothing but OA. The final position vector is nothing but OB, and the displacement vector is nothing but AB. And how do we define the displacement? The line joining initial to final position is called the displacement, right? The line joining initial to final position vector is called displacement, is called displacement, right? It is called the displacement. What is the displacement over here? The AB is the displacement, or you can say the shortest distance between initial and final position is called the displacement, right? It is a vector quantity, right? It is a vector quantity, and SI unit again is meter, right? Listen, one more thing. Some question may be asked in this way. We have to find the displacement vector if the initial and the final position vector is given in triangle OAB. If you apply the vector addition, OA vector plus AB vector, OA plus AB vector is equal to OB vector. The OA vector is nothing but the R1 plus R is equal to R2. So R is nothing but R2 minus R1. That is the displacement vector. Displacement vector R is nothing but this the final vector, final position vector minus initial position vector. In this way, you can find the displacement, right? For example, listen one thing. For example, the question will be given like this. If the initial position is 1, 2, comma, minus 1 and the final position is 2, 0, 3, right? So this is the initial position, this is the final position, right? This is the origin, and if you join this, you will get the position vector. And if the particle is moving somewhere and finally reach to this point, we are not going to find the distance. So how to find the displacement, Vranda? How to find the displacement? This is the initial position vector, this is the final position vector, and this is nothing but the displacement vector. Wherever it is going does not matter. The displacement depends upon the initial and final position. So this is the final position vector, this is the initial position vector. So how to find the R? The displacement vector is nothing but R final minus R initial. How would you write the R final? This is 2i cap plus 0j cap plus 3k cap minus, what is the initial position vector? I plus 2j minus k cap, right? 2i minus I is I, 0 minus 2j, 2j, and this is the 4k cap. So this is the displacement vector for this question. Are you getting this question or not? Right, copy this. So read this question. In this question, a car moved from O to D along the path OABCD. What is the path? This is the O, then A, then B, right, then C, then D, right? And then you have to find the distance and the net displacement. This is the 8 kilometer over here, this is the 4 kilometer over here, this is the 4 kilometer, and this is the 1 kilometer, right? This is the final position D. Is it clear? So you have to find the distance and the displacement in this case. So what is the distance? What is the distance? The distance is nothing but the path length when it moved from O to A to B, B to C, and C to D. OA plus AB plus BC plus CD is the distance. This is 8 plus 4 plus 4 plus 1, right? This is the 17 kilometer. Is it clear or not? So you understand how to find the distance? Yes, it is very easy. And now what about the displacement? I told you the definition of the displacement, the line joining initial to the final position, and this is called the displacement. And how can you find this? Listen one thing. If this is the 4 kilometer, this is the 8 kilometer, right? So what about this? This is also equal to the 4 kilometer because 4 plus 4, and this is the 8 kilometer, right? And what about this distance? Can you tell me what is this distance? No. This is what? 4. This complete distance is what? Say 4. And this distance is how much? say 1. So what? Yes, 3 kilometer. So if this is 4 and this is 3, so what is the OD? The OD distance, this is nothing but root over 3 square plus 4 square, and this is 9 plus 16 is equal to root 25, and therefore displacement is 5 kilometers. You understand this question or not? Right, copy this. So read this question. In this question, particle goes along a quadrant of a circle of radius of 10 meter from A to B. Listen, this is the circle, suppose, right, and the quadrant from this is the AB, this is the A, right, and particle is going from A to B. This is assumed to be the y-axis, this is the x-axis. What is the radius? The radius is given as the 10 meter. So you have to tell what is the distance and the displacement, what is the magnitude of the displacement, so, and the distance. So what is the distance? This path length is nothing but the distance. Is it clear? So if what is the total circumference? What is the total circumference, Vrinda? Say 2 pi r. So half is say pi r. So 1/4 is say pi r. It means, right, the distance along AB, along the quarter circle, is nothing but pi into r, and the r is nothing but 10 meter. So this is the 10 pi meter is the distance. This is the first thing. Is it clear? And how to, yes please. Yes, this is 2 pi r by 2, right? This is the 2 pi r, this is the pi r, and pi r by 2 is the quarter circle. Is it clear or not, you tell? This is the 5 pi meter. Fine now. And what about the displacement? The line joining initial to final position vector. The displacement vector is nothing but AB, but we have to find what? We have to find the magnitude, right? So how to find the magnitude? If this is r, this is r, it will be r root 2. Can I write it directly? This is r, it is the hypotenuse. R root 2 is the displacement. What is r? Say 10 root 2 meter is the displacement. Is it clear or not, you tell? One more thing. Can you tell me what is this angle? In this triangle, what is this angle? Theta. Say tan theta is what? Say 45. 1 is equal to 10, 45. So this angle is nothing but 45. Listen one thing, they are asking the angle between the x-axis and the displacement vector. So this is the x-axis and this is the displacement vector AB, right? Or you may write it is the r. So this angle, if it is 45 degree, so this is the x-axis. What is this angle? Alpha. Therefore, Vs, angle between x-axis and displacement is nothing but 135 degree, right? Copy this. So before going to next question, I am giving you the concept of hexagon, right? The hexagon. What is the hexagon? The 6 equal sides are there in hexagon and this is the center. If the side of the hexagon is assumed to be the A, fine, right? So if this is the one point, this is the another point. Listen one thing, there will be two diagonals. This is the one, another side and the another side. Suppose this is assumed to be the R, right? And the another thing in the hexagon like this, right? This is the big diagonal and you have to find this distance. Also you have to find this distance. Understood or not? How to find? Listen one thing. If you join the center, right? If you join the center, this is the hexagon. I think you understand this. So if this is the 60 degree and this is also 60 degree. You understand this is an equilateral triangle. This is the right. This is the, if this is the equilateral triangle, so therefore the each side, listen, for the hexagon, the angle must be, each angle must be say 60 degree, and these are the two sides are equal, therefore the angle must be equal and opposite. And if you try to find this angle, each angle comes to be 60 degree, and therefore every triangle you are seeing over here, this triangle is nothing but equilateral triangle, right? If it is A, this distance is also A. So can you tell me what is the length of this big diagonal? Tell me. Say this is 2A. All right. What is the big diagonal of the hexagon? Say 2A. Right, Vrinda? You are getting this thing or not? Any doubt in any angle or side? Please tell. I can explain once again. Right, very good. Listen, one more thing. Now we have to find this distance also. Right, copy this and try to find this distance. Right, how, what do you think about this? First copy this, then I will find. Listen, one thing, how to find the x? Can you tell me this angle? Say 60 degree. All right. Can you tell me this side? Say this is also equal to A. Is it clear or not, you tell? Listen, one thing, if you consider this is the parallelogram, right? This is the parallelogram. If I join this side and this is the median, so what is this angle? If this is 60 degree, this is the 30 degree also. All right. So this angle is what? Say 30 degree. Is it clear or not? If you consider this is the triangle like this, right? This side we have found the 2A and this side is A, and if this is what? This is 30, this is 60, so it will be 90 degree or not, you tell? So in this triangle, whatever the name you give the triangle, right, in the triangle, in the right angle triangle, you can apply x square plus a square is equal to hypotenuse square. So this is equal to 4a square, x square plus a square. So x square is equal to 3a square and x is equal to a root 3 is the correct answer. So this distance is a root 3. Now you, although this is the concept, you can find the value of the x by another method also using the trigonometry, right, in some other triangle, but this is the easiest way. I told I teach the students here. You have to remember for the hexagon always, right, this distance and this distance are equal or not, right? They are equal. It is a root 3, it is a root 3, it is also equal to a root 3. Is it clear? If the side of the hexagon is A, so this is the diagonal, or you can say this is the length, it is a root 3. And also, if this is the hexagon, this is equal to 2A, this is equal to 2A, this is equal to 2A. Vrinda, you are getting this thing or not? So you have to understand and you have to remember about the hexagon. Many times the hexagon comes in the calculation in class 11th, also in class 12th, right? So these distance, how does it come? You have to practice once again and you have to remember for final result, right? Copy this. So read this question. In this question, an open ground motorcycle follow a track, right? That turn to his left, right, by an angle 60 degree after each 500 meter. For example, if the motorcycle start from point O, it move for 500 meter, right? It has to go in straight, but it turns to left by what angle? Say 60 degree angle. All right, like this. After covering the 500 meter, it should go to the straight, but it moved to the, it turns to its left. right, by 60 degree. It has to go to straight, but it turned to the left. You understand or not? So, or every time it is turning. So, if it is turning every time by 60 degree, it will make hexagon definitely. You understand the concept or not? Starting from here, this is the first turn, this is the second turn, third, fourth, fifth, sixth, then it is seventh again, and this is eighth turn again. Are you getting or not? So, according to the question, specify the displacement and the distance. Right. Specify displacement. Compare the magnitude displacement to the path. Okay. Ultimately, you have to find the third turn, and for the sixth turn, and for the eighth turn. You have to find the distance and the displacement. Is it clear or not? That is the question. So, at the third turn, right, from here, 1, 2, and 3. So, for this third turn, can you tell me what is the distance, Vrinda? No, from here, this is starting point, first turn, second turn, third turn, it reached to this point. 500 plus 500 plus 500. What is the distance? Yes, it is 1500 meter, right? You are correct. 1500, right? It is correct. And what about the displacement? Line joining initial to final position is the displacement. So if it is A, what is it equal to? Say 2A. So this is the 1000. This is 1000 meter. So displacement is 1000 meter. Are you getting or not? Now what about the 6 ton? What is the total distance covered? Yes, 3000. 506A. This is 3000 meter. Right? 500 plus 500 plus 500 plus 500 plus 500. And what about the displacement? 0. What about the 8th ton? When it reached from here and reached to the 8th ton. What is the distance? No. Distance. Starting from here. Complete one hexagon plus 500 plus 500. 4000. Right. And what about the displacement? A. Right. This is the 500 root 3 meter. Is it clear or not, Yutal? So, right. Compare the magnitude of the displacement and the total path covered by the motorcycle in each case. So, they are asking the magnitude of the displacement, compare, we have to divide it by the distance. In each case, for this case, 1500 upon 1000, right? This is the answer, right? And here it is what? The 0 upon 3000, right? It is 0, it is 3 by 2. And what about this? 500 root 3 divided by 4000, right? So root 3 upon 8. So this is the ratio, or compare, right? Is it clear or not, Yutal? Copy this. So if you know the concept, then so read this question. In this question, particle move on a circular path of radius r, right? It is moving like this, right? And complete for one revolution in 40 seconds. It means one revolution in 40 seconds. Calculate the distance and the displacement. Total time is what? Say 2 minutes plus 20 seconds. 2 minutes is what? 2 into 60 plus 20, right? So this is 120 plus 20, right? 140 seconds. And one revolution, how much time it takes? Say 40 seconds. So total time is 140. 40, you can divide this 40 plus 40 plus 40 plus 20. Is it clear or not? So if particle start from here, so in 40 second it complete one revolution. How much distance it cover in one revolution? Say 2 pi r. Again in 40 second, 2 pi r. Again in 40 second, 2 pi r. In 20 second, from here to here. Right. So what the distance is covered? Say half circle. Say pi r. Is it clear or not? So what is the distance covered in 140 second? 2 pi r plus 2 pi r. 1, 2, 3 and half. 3 and half circle. That is 7 pi r. Right. And starting point is a 1, 2, 3 and finally it's reached to this point. So what about the displacement? Can you tell? No. Displacement is that initially start from here and finally reach to this point, 2r. So line joining initial to final position is called the displacement and it is equal to 2r. Is it clear or not? Copy this. So read this question. In this question, a wheel of radius r is placed and this is the point P on the ground, contact point P. Wheel start rolling without sleeping, mean it is rolling like this, right? So listen one thing and find the displacement of the point P in half revolution. You have to tell. Listen one thing. If this is the circle or the disc, you can say, or the wheel, you can assume, so it is moving like this. So when it complete the half circle, right? So in the half circle, where the point P will reach? At this point. Fine. And in the remaining half circle, again this point P will come on the ground. Is it clear or not, you tell? Like this. Complete circle. So what is this distance? Say 2 pi r. Is it clear? If the radius is r. So can you tell me what is this distance? What is this distance? This distance covered in one complete revolution if the wheel is rolling without slipping. So this distance will be 2 pi r or not in complete circle? Right. And what about in half circle? If half circle we consider, what is the distance travel? You will say it is pi r. Fine. It is pi r. Also it is pi r. So total distance is 2 pi r. Is it clear or not? Initial position of point P is on the ground and in half revolution definitely this point P will reach on the top or not? Yes, it will reach. Right. What is this distance? What is the displacement, you will say? Tell me. Displacement is nothing but the line joining to the final position. Right. So you tell me, if this is the P, what is this distance? It will be 2r or not? And this distance is pi r or not? So the displacement is d. So how to find the displacement? In this triangle, right, this is the 90 degree, pi r whole square plus 2r whole square. If r square is taken common, inside the root, pi square plus 4, you will get. Is it clear or not, you tell? This is the displacement. Copy this. So read this question. In this question, man move right. Listen. This is the, suppose this is the east, this is the west, north and the south. So what, 4 meter towards east. Suppose it start from here. This is the OA. This is the 4 meter towards east. 3 meter along north. Is it clear or not? And then at this distance, at this point, the pole is over there. And this distance is what? Say 12 meter. Is it clear? So finally the person reached to this point, right? So if this is 4, this is 3, so can you tell me this distance is how much? 5 meter, right? And if it is the 5 meter, here the pole is on this pole, he climbed. So this is the final position. And how much length is this? Say 12 meter. 12 meter. So what is the displacement? The line joining initial position to the final position. This is the displacement. Is it clear or not? In 3D, I'm making the figure for you. Suppose this is the east, this is the west, north and south. Starting from here, right? It move for the 4 meter, right? Like this, O to A. This is the initial displacement. Then along the north direction, say 3 meter. Is it clear or not? And in this space, right, in this space, there is a pole like this. There is a pole. And how much distance is? The pole is of 12 meter. All right. So if this is 4, this is 3, how much distance is this? Say 5 meter. And this is the 90 degree, right? This is the pole. Are you getting or not? So O, A, this is B and this is C. So final displacement is this. This is the final displacement. So if this is the 5 meter, this is the 12 meter. So what is the displacement? How would you find? This is the right angle triangle or not? Is equal to what? This is 25 plus 144 is equal to 169 is equal to 13 meter is the displacement. Is it clear or not? In this case, this is the 12, this is the 5 and this is the displacement 13 meter. Copy this. So read this question. This is the simple question. Person move on a semicircular track of the radius 40 meter. This is the semicircular track. The radius is 40 meter. And from starting from point A, it reaches to the point B, right? The distance is what? Say pi r. Say pi into 40 is equal to 40 pi meter, right? And what about the 2r? Displacement is 2r is equal to 2 into 40 is equal to 80 meter is the displacement. Fine. Copy this. So read this question. In this question, a man has to go 50 meter towards north, right? This is east, west, north, and this is the south, right? So 50 meter towards north from O to A. This is the 50 meter. 40 meter towards east. This is the V, 40 meter. 20 meter due south. Now, in which where it will go for 20 meter? Tell me. From here down. And how much it is? Say 20 meter. And reaches to the point C. Right. And this is the home at from here to home. Right. So, A part. What is the distance in the A part? Very good. 50 plus 40 plus 20 is equal to how much? 110 meter. And what about the displacement? The line joining initial to final position. This is the displacement. How would you find? Listen one thing. This distance is what? Say 40 meter. And can you tell me this distance is how much? 30. Very good. And this is the displacement is nothing but root over 40 square plus 30 square. When you will calculate, you will get the 50 meter is the displacement, right? Copy this.